We're really excited to welcome Oren Niskin here. Reduce your OT vulnerability management effort. Oren was a U.S. Navy veteran, served in the USS Harry S. Truman in the reactor department, completing 2 tours in the Persian Gulf. Served as OT security manager for a global fleet of offshore drilling rigs, and holds a bachelor's in nuclear engineering technology and currently pursuing a master's in information security engineering from the SANS Institute. He is a senior OT cybersecurity consultant for GuidePoint Security, and we're excited to have him here. And Oren, the floor is yours. Thank you for your service.
Thank you, Grayson. And you're welcome for my service. So, anytime. So my talk is how you can reduce your vulnerability management effort by 80%. And I made that outrageous because I know it's 2:30. And if we've all seen the 5-hour energy drinks, you're going to have that 2:30 feeling. So you need to stay awake so you can call me out on whatever I'm full of it. So, who am I? Who is this guy that looks like Ray Romano? He's an OT security engineer at GuidePoint. They changed us from consultant to engineer. I'm not sure why, but new title is always nice. I have a wife, 2 girls, 2 boys, 2 dogs, and 4 lizards. A lot of heartbeats in my house. Like Grayson said, started in the Navy as an electrician. I got out, decided to go to wooden boat building school. You can see me there doing wooden boat stuff. After that, turns out can't make a great living building wooden boats. So I went offshore drilling rigs for over a decade, transitioned to the office and took this guy's job, Greg Villano, my hero, took his job managing the offshore drilling automation environments for the worldwide fleet of rigs. So that gave me, I think, unique experience from the bottom of the Purdue level, like at the sensors and the bilge of the aircraft carrier, moving to offshore oil rigs, kind of the PLC level, automation, engineering, automated processes, all these new cool things coming out to make these rigs more efficient, to the office where interacting with IT and bringing in new stuff kind of worked my way up the Purdue model to eventually I got sick of making an honest living and moved to consulting. So I like to say, starting off in the Navy, going to offshore rigs as a electronic technician, going to the office, I have more of a O than T. I'm OT, but I'm much more O than T. So that's trademark, more O than T. So, and I am not Ray Romano. I actually identify as Agent Gibbs. So you can see Agent Gibbs here. I am Agent Gibbs with my wooden boats, super cool. I was in the Navy, he was in the Marines, but from what I'm told, it's pretty much the same thing. All right, we don't have any Marines here, I guess. Oh, yeah, okay. Yeah, you agree, it's pretty much the same thing. I mean, interchangeable. All right, on to the talk. What are we going to be talking about? First, we're going to be talking about the problem. And the problem is patching really sucks in OT. It is terrible. Nobody wants to do it. And it gets left on the back burner. And the solution is to make it suck less. And that in computers in general is automation. Automation is the key. What gets automated gets done. What's manual gets done tomorrow. So don't want any manual stuff. And that is, I think, almost universal across OT programs in general, is the stuff that's manual, the stuff you have to have a million meetings about. It just really hard to get that stuff off the ground. But the stuff that just everybody's on board with and that gets automated and can be done efficiently, that takes hold and really drives the program forward. So our focus is to see how we can move patching from, or vulnerability management in general, from something that is super manual and time consuming to something that's much more realistic to achieve. And we're going to do that by walking down the Purdue level from the industrial DMZ all the way down to the sensor level. And if you have any questions, as you can tell, I'm super strict speaker, so just yell out your question and let's take care of it. So. Oh, yes, I have to repeat the question, though, if you say it. So, yeah. Okay. So what is the problem? I think the problem is summarized really well by these two pictures here. On the left, you have what McKinsey and Company is telling your board. And if you're an industrial organization like power and utilities, water treatment plant, you are a manufacturing facility, or offshore drilling rigs, or anything like that, McKinsey or any business management consultant is telling them two letters, A and I. When I started in this business, AI meant analog input. Now, it does not. So they're telling you, yeah, you have to do AI. Maybe before that, it was green energy. We want to be more energy efficient for the environment, for climate change. We want to new energy sources, renewable energy sources. We want new technologies. We want machine learning. And before that, let's go to blockchain drilling. Blockchain, remember blockchain? And if you think about all these initiatives, they are some of the most important initiatives of the whole company. Like when at Diamond Offshore, it was blockchain drilling. Now that might sound funny right now, but AI, let's talk about AI at, let's say, a power plant. So it's probably an initiative somewhere to hook up these power plants to AI to optimize power generation, power distribution, et cetera. Or if you're a manufacturing plant, I want to use AI to optimize set points for some of my manufacturing processes. Or I know in drilling, they're using AI for various functionality to detect incidents like a hydrocarbon kick. So before your rig blows up, like in Deepwater Horizon, AI is going to let you know, hey, there's a problem. And the sticky point with all these is that you need to connect down into your OT systems to make that valuable. For green energy, if you want to be more efficient, you have to connect down into your OT to get that telemetry off your energy systems to be able to see how can I use my energy smarter. And the problem here is on the right. So on the left, we're saying let's tie OT into all these new initiatives, AI, green energy, et cetera, that are the most important initiatives of our company. And on the right, you see there's more and more vulnerabilities coming out all the time. And they're just exploding as our systems, number of digital systems in the plant explode, and the number of vulnerabilities, these systems become more complex, it's harder to write secure code, and it's number of vulnerabilities just growing all the time. So more connections means our systems are more exposed, more vulnerabilities means there's more risk for each connection. So that combined is the problem. Okay, so this is the second part of the problem. Why is patching so hard? Patching is hard in OT because you can get someone hurt. When you patch this device on the right here, this is a PLC, if you patch that device with a new firmware version, you have changed the engineering characteristics of that device. And that means that the safety functions that that device provided may not be the same anymore. It may change the way this device acts, which changes the way the systems act, which is why your vendors tell you don't just go patching PLCs without involving them, right? Because it changes the engineering characteristics of the system, and that puts everyone at your plant at risk. The second part is you could bring the process down. This has happened all the time. So if you talk to people that have installed, like have had IT involved in a lot of their OT stuff, they'll say IT patched this system, brought the process down. They didn't even tell us they were going to deploy the patch, and we didn't understand why our process wasn't working until we found that out later. So yes, it could bring your process down. So in the end, you could lose a lot of money from downtime. You can get someone hurt. All pretty bad stuff. Oh, I think it skipped a slide. It skipped the most important slide. I am sorry. So we talked about the problem with the more connections and more vulnerabilities. And the way that problem is solved is the most effective way we've seen to solve that problem is to use the SANS 5 critical controls. So do we have, out of here, is there anybody that is a fan of the 5 critical controls? You use it in your programs? There we go. There's a couple people. You're afraid to admit it, huh? Rob Mike. So the SANS 5 critical controls are just 5 things that if you do these 5 things, greatly reduces your risk of an incident affecting your operations, right? So you start on the left side, ICS incident response. Are you prepared for an incident to happen in your OT network? That's the thing that will reduce your risk the most at first. Just be ready. Who would you call? How would you know if there was an incident? How does a person on the plant floor know what an incident looks like? You do that. That's relatively low amount of effort, but in the end, it provides a huge return on investment. Then you go to defensible architecture, segmenting your networks, putting firewalls in place, making sure your architecture supports advanced functions like monitoring. So you've segmented your systems now, start monitoring the network, looking for anomalies, seeing what's going on, understanding what normal looks like. That's a huge risk reduction. Then you go secure remote access, control who and what your vendors are doing on your network, which is a huge risk reduction. And the last one, all the way on the right, is risk-based vulnerability management. And this is, I think, it's a critical control. So it's really important to do, but it's all the way on the right because it's the hardest to do. You could spend a lot of time working on it and you don't even know if you've made a difference. You could spend all this time investigating a patch, getting it approved, you patch the system, and another vulnerability comes out the next day. So it's really hard to show progress and meaningful return on investment from that last risk-based vulnerability management. But on the other hand, if you think about it, if you have a vulnerability, patching that vulnerability is the best way to mitigate that vulnerability. I don't know if Ray stayed in here from the last talk. I don't think he did, but Ray, he was a hacker. He talks about hacking industrial control systems with turtles and alligators. But what he said was he just finds a way around the mitigation. So if you don't patch a system, you're going to put some kind of mitigating control in place. He's going to find a way around it. So the best way to mitigate a vulnerability is to actually patch that thing. You patch it, and the vulnerability is not there anymore. So you don't have to worry about somebody getting around your mitigation. So what I think that means is when people put it on the back burner, they're missing out on a huge risk reduction that's available to us. And hopefully the goal of this talk is to show that it shouldn't be on the back burner, that it deserves the same effort as the rest of the critical controls. So I think we talked this one. So I've been doing this for over a decade, I would say, starting off on the rig itself, where we would be part of the patching and we would be part of the process to take this system down, to patch it, to move on to the next one. Then in the office, managing the process and putting in the controls in place and reporting back up to our clients, and then consulting, helping a variety of clients. And in general, this is the way it went. We would get visibility. So I actually took over at Diamond from Greg Villano, and there's great videos of him on YouTube explaining how he started the program pretty much from scratch. And we were one of the first customers of Clarity. In fact, Clarity wasn't even a company yet. It was still Team 8. So we had visibility, which was back in then pretty rare. Back in the day, like 2017, 2018, it wasn't exactly normal to have visibility. So we had visibility, which was awesome. And so I said, wow, we have all these assets, all these vulnerabilities. I'm going to do a risk assessment, and I'm going to order them from highest risk to lowest risk and start knocking them out. And what happened was I hit just a huge snag that I would say, okay, the highest risk is this driller's chair. That's the most critical asset on the rig, and it is vulnerable to all these things. We need to patch it. And it was very difficult to get that thing patched because you had to take downtime to patch it. It was, if the patch goes bad, can you 100% assure me that we could roll back to the way it was before? Can you 100% assure me that all the safety functions are going to work afterwards? And all this discussion, all this effort in general, by the time it was patched, a new vulnerability came out. So in the end, trying to manage vulnerabilities across the environment, I felt like I was falling behind constantly, and I was really stressed out. So it was hard to show progress. My bosses, frankly, were getting a little impatient with all my my efforts to do vulnerability management, and there was like a strong tendency for me to fall back to those other critical controls, like, oh, I'll do vulnerability management later. Like, you can't really do it in OT anyway. You know, you probably hear a lot of that. So I thought that was a problem. And it changed. One day, I was in a QBR, quarterly business review, I think it is, with ABB. And I don't know, do we have any ABB people that operate ABB, or somebody from ABB? Yes, okay. So they're very smart people. And one of them, I think his name was Trond, although could have been something else, very European. But he leans over to me because they're at the end of the QBR, they like to pitch their new services. So he leans over and he's like, "Tell me something, Oren. What do you think if we like patch all your Windows systems automatically?" And I was like, "What? You can't do that. You're going to bring the process down. You're going to get people hurt. You can't just patch OT automatically." And they said, "Well, we've considered that, and if you think about it, the Windows systems in your control system are diagnostic systems. So if we patch them and the patch goes bad, we can't do remote diagnostics." It's called a drive monitor. So I don't know, did you have drive monitors in your? Oh yeah, so he has drive monitors. So drive monitor, if the drive monitor goes down, they can't remotely help you fix problems with your ABB drives, which is a problem, but it's not like I was saying, like some people are going to get hurt and the process is going to go down. It didn't affect the process at all. But at the same time, it was the most exposed. So that's the thing that Ray from the last talk is going to find and get to and cause harm, is that remote diagnostic system. So being able to patch that system automatically with their tested patches, which they don't have a spare drilling rig to test it on. So that is, I don't know how much of testing really helps, but at least it helped that it didn't make a blue screen. So the point is, we were able to implement patching automatically. I didn't have to deal with it at all, and reduced our risk a lot. And it was a big aha moment for me. Like, for some reason, I had this mental block up until that point that you can't patch anything in OT without having all this risk assessments and vulnerability, meetings with rig management, et cetera. Like, I always thought it was just a no-no to patch anything. So it was a big aha moment for me. And in fact, our client, one of the big oil companies in Houston, they said, "Hey, in your last report, you forgot to say how you are mitigating not patching your ABB systems." And I said, "Well, it's because I am patching my ABB systems." And the guy was like, "No way," he couldn't believe it. And it was a big aha moment for him too. So I hope you have one of those aha moments where you just make your client so happy. And so I think it was a big change in my perspective and what kind of brought about this talk on how we can more formalize and think about digging a little deeper and seeing what we can actually patch and not patch. Okay, so I don't know if any of you have seen this. This is the Department of Homeland Security decision tree for how to do patches. And this is what I was used to before talking to ABB. So you have a vulnerability that gets identified. Now, this can come from the vendor product notification or even from regulators. So offshore, we had the Bureau of Environmental Safety and Enforcement, I think, and they would send things saying, "Hey, you need to mitigate the risk of these vulnerabilities that are common in control systems." And so we would take that into this decision tree and we would say, "All right, is a workaround available?" Well, in order to see if a workaround's available, we need to meet with some people, right? We need to see if we can have a workaround that would be acceptable to the engineering group to be able to mitigate that vulnerability, something that would not affect the safety of the system. Next, we're going to say, well, are the operational needs greater than the risk? Because if you install a patch and it increases the risk of your system, that doesn't work. So you want to make sure your operational needs, you want to make sure that your patch doesn't negatively affect the operation of the system. And in order to do that, you need to meet with some business people. So you met with the engineering people, now you need to meet with the business people. The business people have a rig to run or a plant to run or a manufacturing line, et cetera, and they're really busy. So you finally meet with them, work some way out, you analyze the risk for this vulnerability, this patch, whether you're going to patch it. Now you need to schedule the patch. That's more meetings. And you see what I'm doing here. There's a lot of meetings involved. And does everybody here love meetings instead of actually getting work done? I'm assuming. He loves me. Okay, yeah, he loves me. Really? It must be the Marine Corps thing. We love meetings in the Navy, too. We're pretty much the same. He knows, we love meetings, right? Out. Yeah. Oh, so yeah, it's a lot of meetings, and I don't know about you, but meetings are the enemy of getting work done. So if I can minimize the number of meetings, I told Sam in the interview before this, if I could prevent one person from having 1 hour of meetings, then I think we've done our job at this talk. So, yeah. All right. So you can see there's a lot of meetings here, and this is what makes it unsustainable. This does not scale. This model of all these meetings and all these decisions does not scale if you multiply it by all the various systems you have and all the vulnerabilities. So we need a smarter way to think about this. And this is the path to enlightenment, automation. And the thing to think about here is going back to that decision tree and seeing if we can find devices that just work their way through that decision tree automatically, and you don't need to have any meetings. That's the advantage. That's what we're going to try to show. So what if we could roll out patches to the highest risk assets automatically? And that is what that ABB guy taught me. Some of these devices, they are not safety critical, they're not process critical, they're in your OT network, and they're the highest cyber risk, highest exposure. So, yes. I don't know if you've seen this, but this is a mock-up of the Purdue model. The Purdue model, they say, is dead, but somehow I keep seeing it pop up in every single OT talk. At OTSecCon, the greatest OT conference in the world. So, so this is the converged plant-wide Ethernet standard from Cisco and Rockwell. So the two big names in networking and automation. They came up with this based on the Purdue model, like I said, and it focuses around, it's a really detailed method to architecting an OT network. If you have not seen it, I would recommend it as objective and very specific way to how to build an OT architecture, right down to the Cisco command line of what you type in. It's really useful. And it starts at the top there with the industrial demilitarized zone, and it goes down to, so the industrial demilitarized zone is where everything comes into and leaves the network. If you have a connection coming into the OT network, it should first terminate in the IDMZ and then continue on. So this is your most exposed network. This is the one Ray, the attacker from the last talk, is going to be attacking and exploiting. Then you go down to level 3. So level 3 is things that is going to go across your whole site. Like let's say you have a backup server that's going to back up things across your site. That's going to be in level 3. Or maybe you have an engineering workstation where somebody logs in and they could fix various things around the entire plant. That's level 3. Or you have here remote access. So somebody remotes in, they get access to whatever systems they need to from that level 3. And then you have the cell level down there. It's kind of a mixture of 2, 1, and 0. This is going to be like your manufacturing line, line 1, your 12-ounce can line for soda people, or your a certain system for your power generation facility. It could be, if you're in a car manufacturing facility, it could be the paint shop, or it's just whatever cell of your process. You want to segment that as much as possible and have each cell its own thing. And this is not only for security, but it's for reliability, so they don't interfere with each other. Because I think networking issues probably take down a lot more plants than security issues. But this architecture gives you kind of a jumping off point to do really efficient patching and just management in general. So let's start off with the industrial demilitarized zone. And this is the key slide. If you take any slides away from today, this is it, this slide. So the industrial demilitarized zone is, like I said, the place where the attackers are going to be scanning and trying to exploit systems the most. So it's your most exposed network. But at the same time, I would not recommend putting things in here that are critical for safety. Like, you wouldn't put in a safety critical system in your industrial demilitarized zone, obviously, because industrial demilitarized zone sounds terrible. You would not put things that are even critical to your process in the industrial demilitarized zone. So it is the highest network exposure, but hopefully it has no systems in there that are critical to your process or for safety. So if you think about it, it is both the most exposed and the easiest to patch. Because if you patch it and something goes wrong, that means your process is still operating. It's just your whatever function in your DMZ is not working anymore. Your process continues to operate. All your employees at the plant are still safe. It's just need to recover that snapshot to the earlier version. And that brings me to the next point. Usually these are all virtual machines. And if you think about that, if a patch goes wrong on a virtual machine, on a server infrastructure, usually you have snapshot backups, and you could just restore from your snapshot. And since your process is still running, probably no one will even notice. So this makes automatic patching of your industrial DMZ a key way to achieve a lot of risk reduction with a lower amount of effort. And since you could patch these faster, you can keep the attackers out much better. And as you do those initiatives with the AI and the green energy, and you're tying in more systems here, your patching keeps this network and those connections more resilient and bridges that IT and OT gap in a safe and secure way. So this is the key network you get the most value out of. And this is level 3, the next one. So we're automated patching our IDMZ. Level 3 is the next level. It is the second highest exposure. So after somebody goes through the remote access gateway in the DMZ, they're going to go onto a remote access server, probably in level 3. And from there, they're going to be able to access a lot of hosts, maybe, potentially in the OT network. So that is your second level of exposure. But at the same time, you should not put safety critical equipment in level 3, I would say. Like, if you're going to monitor a critical pressure, that monitoring of that critical pressure will not happen at level 3. It should happen at a lower level. So this is, while it is the second highest exposure, it is also maybe a little more critical than the DMZ, but not super safety critical like the ones below it. So you can also patch in level 3. And specifically, if you look at each of these, you work out which ones are critical and which ones you can patch. So there are also virtual machines, just like the DMZ. So if a patch fails, you could just roll back to a previous snapshot. Talking really fast. All right, level 3. So specifically these two systems right here, the engineering workstation. If you have an engineering workstation at your plant, you patch it, and the patch goes wrong, your process should continue running. You may not be able to have engineers work on it, troubleshoot it, which could be an issue, but your system continues running. Nobody should get hurt. It shouldn't affect safety at all. This just affects your engineer's ability to troubleshoot the process. So something like that can be patched much easier than these safety critical systems. So Remote access server, the same applies. You may lose remote access if a patch goes wrong, but you should be able to continue running your process. So all those concerns I had all those years about patching an OT, about taking down my process, getting someone hurt, causing quality issues, it doesn't apply to these two systems. And if a patch goes bad, I'll just roll back to a previous snapshot, and remote access will be restored. And this is the key thing. And this gives you the second biggest risk reduction. After your DMZ, you're level 3. So it is a little bit harder to patch than the IDMZ, but it also gives you just a little bit less value. So IDMZ is really where the magic happens. Level 3, almost as good, but not quite as good. And this is where it gets hard. So levels 2 to 0, I don't know, there's not a lot of value in patching at this level. So if you were listening to Ray's talk just now, he was talking about how once you get down to this level, he's not really exploiting vulnerabilities, because at this point probably has maybe valid credentials or could just write to these systems, since a lot of them don't even require authentication. So if there's a vulnerability in a PLC at this level here, let's say it's a PLC and there's a critical set point for pressure, I could change the alarm set point on that PLC without exploiting any vulnerabilities. A lot of these have no authentication. So I don't know why I would use a vulnerability that's going to raise an alert in your monitoring system versus just quietly modifying that set point, which could probably go under the radar, because people modify set points all the time. It just looks like normal activity. Or a user that you have credentials for, just log in and perform your action as an authorized user. Very hard to detect. So at this level, the vulnerabilities patching the vulnerability becomes less valuable. And on the other hand, so it's less valuable, it's also really hard to patch things. Because if you patch something at this level, it may affect safety. Like that little, a screen on the side of a hydraulic unit. If you patch that screen and the patch goes bad, and all of a sudden the operator can't get alarms or doesn't get alarms and doesn't realize that a system is in a dangerous state, that could affect the safety of that system. That person can get hurt. Hydraulic systems, they never let me near hydraulic systems on the rig. I was not mechanically inclined. I'm more O, but on the electrical side of O. I don't get near the mechanical side. So, yeah. So these systems at levels 2, 1, and 0, they are both low value to patch, and they're also really difficult to patch. They're not usually they're not usually virtual machines. You can't just take snapshots of them in your hypervisor and restore. It's much more difficult to patch these. Usually you have to call the vendor. The vendor's going to come out, charge you a bunch of money. It's all around miserable experience, but still important. So some of these systems, you could see this. I don't know who hasn't seen this picture of the ransomware on the Unitronics. Oh man, this is great. This is a politically motivated ransomware attack on Unitronics water control systems, and this is.
It's in a lot of breweries as well.
Oh, it is in breweries, critical infrastructure. Really?
Water utility in Pittsburgh and a brewery both got hit with this.
Pittsburgh. Shout out to Steel City, OTSEC. So Pittsburgh, that is fascinating. So if you think about it, these systems at level 2, they may be difficult to patch, but some of them, it's really good to patch them. And this is where that decision tree comes in. So if you have a brewery and you have a level 2 device that is running Windows, I've seen a lot of, not just, this is kind of sensational, but I've seen a lot of just WannaCry, Configure, that is quietly bringing these plants down. Like it's funny, you go there and they're like, yeah, every day, a couple times a day, our network just stops working and we just we take a break for 15 minutes so the network calms down and we come back to work. Like, this is things that actually happen. They have no idea. And then you get a packet capture, and it's just full of WannaCry and Conficker fighting each other. And it's because these systems, they don't get patched, and they're susceptible to worms. So you want to selectively patch them. It's more difficult. You use your DHS decision tree. This is where that comes in. And you could focus your time on doing a good job patching these systems. Some of them, of course, you see that right here, this engineering workstation, you could patch that thing. And you have two operator interfaces. So a lot of times what I've seen is for that brewery, one person's making beer on one operator station, you could patch the other one. And as long as that goes okay, then you can go back. But beer is critical infrastructure, so don't mess it up. So the point is that this is where it becomes difficult, but I think a lot of times the effort is worth the return is worth the effort. That's what I'm trying to say. So this is where I got my 80% from. My 80%, it came from that gray. We're going to automate that because it doesn't affect the process, right? So you might automate the DMZ first on a really fast pace. You might automate level 3 at a certain, maybe quarterly. Level 2, you could do the gray ones quarterly, but the red ones, maybe you only do those once every, maybe 2 times a year or something. Not very often, but often enough that you've patched WannaCry by now is pretty much the concept. But and that's based on risk, based on and the bottom part, the sensor level, where it's insecure by design anyway, and we talked about Ray is just going to go in there with valid credentials or just modify it with no authentication. We want to segment and monitor it. So segment it so whether it's a vulnerability or an unauthorized modification, it's not accessible for the attacker to exploit. And monitor it. So thank you, Greg, for getting us clarity on that rig. But easy to piggyback off his work. But monitoring, that tips you off to detect when both a configuration change and somebody's exploiting a vulnerability. These monitoring systems love vulnerability exploits because it's a signature they could write, and somebody goes in there loud and exploits a vulnerability, you're going to get an alert, and it looks bad, and it's easy. But to say that somebody modified a set point at 2 a.m., I'm not calling the plant every time, because if you call the plant, you have three strikes and you're out. That's my experience. If I call the plant 3 times and they're like, yes, that was us, we modified that set point, that's what we do here. And they're not going to answer the 4th time. So having that visibility, really useful. And I wish I could say this was all my idea. But as I said, ABB really brought me into it. And Dale Peterson's talk. So this is from 2016. So this is a really long time ago. And you see there, priority 1. This is how you should prioritize your patching according to him. Priority 1, computers accessible from corporate or external network. That sounds familiar. That's your IDMZ. You want to patch that as much as possible. And it should not be required for operation. This is part of a YouTube video. I snapshotted or screenshotted this from a YouTube video, which I can give you. It's a really good talk. It goes over pretty much an entire OT program, and it's still 100% relevant today as it was back then. Priority 2 is computers accessible from priority 1. That's your level 3 in the Purdue model. So we want to do that quarterly. Attackers will compromise priority 1 and pivot. So they're going to get into your DMZ, and then they're going to get into level 3. So that is that's the first 2, and then the priority 3 is everything else, and that's the yellow part and the red part on the previous slide, where you want to do it. This says annual, maintain a supported system, and that brings up another good point that I like to talk about is patching is not just for security. We think patching when they patch their systems they're doing us a favor as security practitioners closing up a vulnerability. But if you think about it, patching is also great for operational resilience. You want to keep your systems in support. I don't know if anybody's tried to talk about, to call Cisco with out-of-date firmware, but they are brutal. They're like, call us back when you install the latest version. This is, the firmware is 5 years old. Sorry, we can't help you. And so the plant, actually, I found out, really likes it when we help them with patching their systems because they get a supported system. They get somebody to help them keep this thing in support with their vendors. And my last point is defense is doable. So I think a lot of times in OT we get told what we can't do. And hopefully this talk has told us maybe a little bit what we can do, empower us a little bit to take more action. And last thing is we have an amazing community. So I got Greg and Juan Negrete. I was started my career managing these oil rigs and got to know that there is a huge community of practitioners out there that really, I think the cyber community in general is really good, but industrial cybersecurity, there's something special about in the industrial side that we all want to see each other go home at the end of the day with all of our fingers and all of our toes. And competitors, vendors, anyone in the entire industry, it's ubiquitous across. When we step on that plant floor, safety-wise, we're not competitors. Cyber-wise, we're really not competitors. We're all in this together, and that's a great thing. So if you have ideas, share, and if you have questions, ask. Everybody loves it. And this is references and my QR code to Venmo me money. No.